Hello student, in this video we will study about the elementary operations of a matrix, or you can say transformation of a matrix. Before it, we will study about invertible matrices, or you can say inverse of a matrix. And what do you mean by first invertible matrix, or you can say matrices? Let if A is square matrix and same let B is also a square matrix, with same order pair, then we will find the product of AB is equal to BA is equal to I. I denote here identity matrix. I denote here identity matrix means if order pair is 2 by 2, it is identity matrix. Means principal diagonal is always 1 1 1. If the matrix is 3 by 3, then all 3 ones are there. Then AB is equal to B is equal to I. Then we call A, the inverse of A is equal to B. Similarly, the inverse of B is A. Means A is the inverse of B and B is the inverse of A. Then we called A is the inverse of B and B is the inverse of A. Clear about the invertible matrix? Then we have a theorem for it is very important theorem. The theorem is if A and B are invertible matrices of same order, then prove that AB inverse is equal to B inverse of A inverse. Clear? This was the theorem number 4. Then proof. By the definition of inverse, by the definition of inverse of a matrix, we have AB and AB inverse is equal to 1. Then we multiply both sides with A inverse. Then it will be A inverse, then it will be AB, and AB of inverse is equal to A inverse with 1. Clear? Means we have A inverse 1. Then do the product A inverse with A, this B as it is, then A inverse of B is equal to A inverse with, it is A inverse. Then we have a formula A and A inverse, we have a I. Then we A inverse with A, it is I with B, then AB inverse is equal to A inverse. Simple. Then I with B means I with B is always B. Simple. B, it will be A, B inverse is equal to A inverse. Again we multiply both sides by B inverse. It will be B inverse with B and AB inverse is equal to, we have A inverse B and V inverse. Clear? Then B inverse with B, it is simple B, or it is I, then AB with A inverse, then we can write, because they are in multiply, B inverse first, then A inverse last. Then I with multiply, this is the same number, is equal to B inverse dot inverse. It is hence proved. Clear about the theorem 4? Now we will study about the elementary operation of a matrix. We will study about the elementary operation we can apply these operation either on a row or a column. If we apply row wise or column wise. If matrix is given, suppose we have any matrix, it is 4, 3, 2 and 7. Then we can interchange here. Means R1 can interchange with R2. Same column C1 change with C2. Either C1 change with C2 and C2 change with C1. Same R1 change with R2 and R2 change with R1. It is rule number 1. Or we can multiply with any constant. Suppose we are taking 5. Any constant. Any. Same, we have a column, we can multiply, suppose C2. Means, clear, it is C1. We can multiply with R1 with 5. Then it is applying. Before applying the operation, we write applying or operating. Clear? Rule number 3. Suppose we want to change in R. This is the sign of arrow. We want to change in R. Then R1 plus R2. We can add. Same, we want to change C2, then we write 2 first and 1 after. Rule number 4, we want to change, suppose R2, then R2 minus R1. Same here, we want to apply on C1, then we write C1 minus C2. Rule number 5, then we want to change at R1. then R1 plus twice of R2 means this will be same with this one. If we want to change with R1, first we write R1. We want to change with C2, then it is C1 with twice of multiply. Clear? These are the basic rules for the applying elementary. It will be row wise or a column wise. Clear? Again, I am going to repeat these rules. We can, if we apply the operation or row wise, either we can change row 1, if row 1 change with row 2, either row 1 change with row 3, row 3 change with row 1. Then we can multiply any constant with any row or a column. Clear? These are the main basic rules. By using these rules, we call it is a elementary operation. We can find the inverse of any matrices. Clear? So exercise 3.4 is mainly depend on these elementary operation or a row operations. So we need to clear all these operations rule and make a proper mind map of these operations. Then in the next video we will solve the NCERT question of exercise 3.4. Thank you, students.